networks, a topic. This is a very long topic. This is all part of the exchange data topic, and networks is network. We're going to start with network introduction. We're going to see how far we go. So, benefit of networks. A network is a collection of connected computers. These computers are known as nodes. These computers can communicate by sending data between themselves. So why you would want them? Data exchange. Data can be sent between computers without the need of external storage. If one thing crashes, you can still use all your stuff in something else. A network manager can manage other computers over updating software, fixing problems, and help users. So if something happens to a solo user, they're not stranded. And you can share resources like printers, scanners, and internet. So, what's an example of a task that a network administrator must do to help a user? Reset their password, and that would help them because, like, why not? So, network administrators can update software, solve problems, help users. So they can help users. Solve and fix. So fix problems. So network performance. Loads of factors affect the overall performance of a network. First of all, the topology. So the star topology is a topology in the middle with connectors outwards. So it kind of looks like a sun. Bus topology is a topology which is a straight line, which starts with a main server and then has nodes coming off of it. A mesh or a full mesh is every computer is connected to every other one. So if one line stops working, the rest of them can work. So wired and wireless. So the main benefit of wired is everything's a lot quicker. Whereas wireless, it takes a lot longer, but there is less like hardware needed, e.g. wires. Bandwidth. Bandwidth is the amount of data that can be transferred at a given time. So say you have two internet routers, which are exactly the same. One router has one PC connected, one router has 10. So, for the internet, it will be, for the one which has 1, all 100% of that bandwidth will be given to that one device. While the one with 10, 100% of that bandwidth will be split with 10 ways, so 10% each. Thus meaning that it will get a lot less bandwidth. Choice of hardware, so choosing fiber optic cables over copper cables would make a difference. Choosing quicker processors, better servers, better internet connections will make a lot bigger difference. So terms relating to network performance, topology, so how they're set up, and bandwidth, how much of the actual stuff they're getting. So factors which affect the speed of a network. So the available bandwidth, which I've explained, wired versus wireless, choice of cabling and other networking hardware, and topology of the network, so how it actually looks. So a network is a collection of something computers, multiple computers. A network is a connection of connected. Well, yeah. So these are all connected together by a central server. So what is the name to describe how the computers are laid out? Topology. Simple. So now, types of networks. That's what we're doing next. Casual 100%. Lovely. Love to see that. So, types of networks. There are also network protocols, the internet, DNS, layering, packet switching. So, types of networks, LAN and WAN. LAN is local area network. That is over a small geographical area, e.g. your house, universities, and small companies. WAN. These are over a large geographical area, e.g. London, Manchester, etc. And the biggest WAN is probably the internet. So, where would local area networks, LAN, typically be found? Home, university and schools, and small companies. Or businesses. Small offices, yeah, companies. So, a something area network is a collection of something connected over large geographical areas. So a large area network is wide. I still think of LAN. Wide area network, collection of LANs. Here's LANs, is local area networks. Collection of computers. Well, it says computers, but it's really the LANs. So, example of geographical classification. A network which is usually rented from a large telecommunication company, that's a WAN. And a network which is usually set up and maintained by the organization is a LAN. That's something like your school, etc. So now, network protocols. This takes bare long to load, to be fair. Like, why does it take this long? Audio is recording is fine. So network protocols. For device communication, they need to mutually decide on a set of rules for how the communication will take place. These are called the network protocols. So what is a protocol? These are how communication should start and end, how data is constructed, what network port should communications take over, how to check if the received data is correct, and what to do if something goes wrong. So a network protocol is a set of rules that define how data is transmitted between connected devices. So, how communication should start and end, how data should be structured, which area port, that's not spelled port communication should be over, and how to check if the received data is correct or not. So, transmission protocols, this is TCP. The one you need to know is the TCP IP unit. So, TCP splits data from applications into small things called packets. These packets then move around the computer. So say when you have a computer, if you were to send stuff to another computer, this would be sent through packets of data. So say if someone were to hack you, they would only get access to a certain part of that data, so they wouldn't really be able to do much with it. So each packet has a header and a payload. The header is how the packet should reach its destination, and the payload is the data that needs to be sent. Wi-Fi is a set protocol of how data should be transmitted using radio waves, as wireless, all of you have it. Internet protocol of IP is how data packets should be sent between networks. So like things have an IP address. Ethernet is how things are physically transmitted, e.g. an Ethernet cable. So IP, Wi-Fi and Ethernet. The header of the TCP packet contains data on how packets should reach its destination. The payload is the actual address of the data we want to send. It's not the address. It's the actual data we want to send. So packets contain a header, which is where it needs to go, and the payload, which is the stuff. So which of these statements about the Wi-Fi is true of the Wi-Fi protocol? It's used in wireless. Simple. Do we always need a protocol when two devices exchange data? Yes, because it declares the set of rules. Ethernet is a protocol which defines how data should be physically transmitted in a something network. It's a what network would this be? This would be a what network would it be? In a wired network. Well, I knew it was physical, but like, yeah, that makes a lot of sense. So now the internet, or the interweb, however you want to say it. We choose Mexico. You didn't really give us many options there, did you, Chief? Just use these as your break period between them. Mexico is here, and Chinchiani Ashua is... Mexico's down there! Oh no. Oh no. Well, that's disappointing. Never have to do geography again though, so it's fine. The internet. This is a WAN. Packet switching. Packet switching is a process in which data is transmitted across the internet. So it's split into packets, which are sent down the network, and routers pass the data from the packets, between the networks. So the Internet Protocol is a set of rules that define how different things should work with each other. And Internet traffic, there are a lot of different types of traffic on the Internet. Each type of traffic corresponds to a different type of application. So there are 4 types of traffic: the World Wide Web traffic, email, mobile game, and streaming. So switching is a process by which data is transmitted on the Internet. The Internet is a wide collection of computer components known as computer networks. EC. Computer networks means like the router. So a URL is a unique identified resource on the Internet. It always follows a specific format. So that format is the protocol. So HTTPS is the main protocol. Then the domain. So in this case, I can't actually show you, but this is https://academicalearning.com, and then next is the path, so where specifically in the website. So this one is classroom/courses. So we're all following a part of the URL protocol, the path, and the domain name. So yep, there we go. That HTTPS is used to send these pages. Where is the Internet Protocol? A set of rules to make sure the devices can work together on the Internet. Yes. This protocol tells us the something which set of something is used to get the resources. So this protocol tells the website client domain. Yep, it was close, I guess. Can you shut up? Protocol. Okay, that took a while. Is not the Internet, it's a browser, which is well, it's not exactly a website. What's the purpose of the domain in the uniform resource locators URL? Set of rules which will communicate with the server. The name of the server we used to, the name of requested file. So the uniform resource locator. Oh, that's actually kind of obvious, considering it has the word locator in it, I hope. So that is the specific thing. Never mind. So part of the uniform locate URL. So domain. The protocol is a set of rules. Domain is the name of the server, and then the path. Simple. So next is DNS and Web Hosting. So in that case it would be, wait for it, it takes a long time to load. Any time today wouldn't hurt in the slightest. Not at all. There we go. When a client sends a request to the server, it has to use an Internet Protocol address so we can find the correct server. Modern web browsers allow us to enter a domain name instead, which the DNS translates. So why use a DNS? Domain names are much easier to remember than a lot of IP addresses. So basically IP addresses are the string of numbers, e.g. 111.000.777, while the domain name may or may not just be Seneca. So computers have to use IP addresses to communicate over the Internet. So the DNS, which is the domain name service, translates the domain name into the IP for us. So DNS lookup. When we have a domain name, we send a request to the nearest DNS server asking for the IP address associated with that domain name. The DNS server responds with the correct IP address. The client then uses the IP address to send the original request. And DNS miss. If a DNS server does not have an IP address associated with a particular domain name, they can ask other DNS servers if they know about it. Thus, a larger DNS server will eventually find the IP for the original client. So it'll find it regardless. So what happens when we do a DNS lookup? So the client uses the IP address to request the original resource. No. So Client sends a domain name. The DNS server sends the IP address to the client. Nope. The DNS server looks up the associated IP address. DNS server sends it to the client, and the client uses it. Simple. So, whenever a user tries to access a website, they will use a domain name, but the computer needs an IP address to be able to communicate with the actual server. So web hosting. Web hosting is the act of keeping a website on a server and allowing clients to request to see the pages of the website. A website is a collection of web pages which are linked together using hyperlinks. A user can click on a hyperlink to navigate the website, so e.g. obviously the different tabs. Hosting a website. A web service is a dedicated computer on the internet which responds to HTTP requests by returning web pages. Setting up a web server. Some people choose to host their own website, but this can be difficult because there are a lot of security risks. They're expensive, and you need to make sure the server doesn't go down. So hosting providers. Loads of people have web hosting companies. These would charge you a monthly fee to be able to host your site. So these guys regularly back up your site, apply security patches, and host your website, which is a lot better than you doing all of that by yourself. So web hosting is the act of keeping a website on a server, allowing clients to request to see pages on that website. So problem of hosting your own website. There are security risks. They're expensive, and the server may go down if there's like a power cut or something, and that means that like you're screwed. So why do we use domain names instead of IP addresses? Humans remember words better than letters. A web hosting company will charge a monthly fee in order for hosting your website. Simple. So now layers. So USA Miami. Where's Miami? Miami is on the coast of somewhere probably. It is. Where do I remember from Austin Alley from here? I was close. I was very close. So layers and packet switching, and then network hardware, and however else far we get with this. So layering concepts. Protocol layers models are often used to be able to conceptualize the many different network protocols. Protocol layer models. In a protocol layer model, a protocol layer is simply a group or collection of network protocols that work at a similar level within the networking process. Layer properties. Layers of the protocol layer model should be independent of each other. Layers should only interact with each other by considering the inputs and output of that layer and how it works. And layers are everywhere. They are not only used within networking. Layers are one example of a technique called abstraction, which helps to simplify problems. Layers are normally helped in software development, for example, a user interface, processing, and database. So database is obviously where all the stuff is kept, processing is where all the maths and stuff happens, and the user interface is the stuff the user uses. So, which of these should layers consider about other layers? Inputs and outputs. Inputs and outputs, that's it. That's all they should care about, I think. It should be independent. They should only care about the inputs and outputs. Yeah, they don't care about how it works. I just didn't want to get it wrong. So there's a user interface layer. There's a processing layer. There's a database layer. And I've been through what they do. So the 4-layer TCP IP unit or the 7-layer open system interconnection model are two of the best known protocol layer models. The TCP model, the application layer, this creates the data, creates and interprets the data, transporting. Then you split and join the data. For example, you split it and then you send it across something. Internet layer, add the address, network access layer, convert data into electrical signals. The OSI model is very similar but has 7-layer. Application presentation session, transport network data link physical. I'm not remembering that. And if you compare them, the first 3 layers of the OS model are grouped into TCP's application layer. The transport layer is the same, the OS's network layer is called the internet layer, and the bottom 2 are in the network access layer, so they are basically the same thing. Just one is in 7, one is in 3. So this is the transmission control protocol model and the open system interconnection model. So this one is the application layer, the transport layer, the internet layer, and the internet access layer, I'm pretty sure. Application transport, yep, internet access, perfection. So now, advantages of layering. Each layer is self-contained but is able to send and receive data to and from layers above and below it. Layered independence. As long as the inputs and outputs of the layers remain consistent, the layers can be changed and it won't affect other layers. This allows layers to be able to improve their efficiency without compromising other layers. So when you debug, you can debug within specific layers so there won't be issues in other ones. Application development. Application development can create network applications without knowing the details of how a network physically works. And specialists. Software developers and engineers can be employed to work within one specific layer. This allows people to specialize in one area. So layers may be improved for efficiency without affecting other pairs of the system, as long as the inputs and outputs are the same. That's obviously because that's the only thing the layers care about. So the advantages of layering is specialization, promotes application development, debugging, and layer independence. So our layers only used in networking? No, they are not. They're used in all parts of everything. So splits and joins layer and converts data into electrical signals. So transport layer, and this isn't random access, it's processing access. No, it's not processing access. So what is it? Is something access. What are you access? Network access. Network. Yes, network access. Simple. So advantages of layering. Can improve layers for efficiency without affecting others. Can fix issues in individual layers. Debugging can be employed. Is it not? Something can be developed without knowledge of networking. So independent specialists. Software designers and engineers can be worked within. This allows people to specialize in one area. So specialized can be developed without knowledge of networking. Specialists can be employed, so they can only be in their part of the layer, so they don't actually have to do other things. And then applications can be developed without everyone being alerted and being annoyed. Why does layering allow people to specialize in one area? That's because people can work on one layer without having knowledge of the others, but they don't have to care about them. That one took a while. So, if we look in this section, there are, oh Jesus Christ, there are 12 parts of this. We are halfway through. What is a packet? When data is split into packets, it is bundled with extra information, which tries to make sure it reaches destination safely. So payload. Payload is the actual data, and the header is the thing which has the address, so it has to be sent. It also has the check sequence number, so that would be able to rearrange packets because the packets are sent in random orders. So what's the payload? The data that was intended to be sent. So a something number includes inside the something, so we can rearrange the packet. A sequence number is included inside the packets. Oh, not packets, sorry, header. Yeah, so we can rearrange the packets. So, how do packets get routed? Packet switching is a process of breaking down data into packets, sending them across the internet to other computers and reassembling it. So, the sender would generate data in an application. The data would then be split into packets. The internet protocol would add an IP address to each packet, and the packet would be grouped into frames and sent across the router to a LAN. This would then send it across a WAN, and each packet would be sent from the sender's router to the destination. Then at the destination, all the packets would be joined back together by their sequence number. Simple. So a frame is a group of data cables. I don't think it is, Chief. Yeah, data packets. So packet switching is a process of breaking data down into packets, shock, and sending them across the network. Okay, so it's internet. Across the internet to another computer and then reassembling it. So, does my data arrive safely? Interface across the network can cause data to become corrupted as it transmitted to the recipient. Checksum. A checksum is a piece of data which is generated from the payload. When data is assembled into packets, we calculate the checksum and send it along with the packet. When the data is received, the recipient can recalculate the checksum from the data they received and compare it to the checksum they received. So, if the values are different, then the data was corrupted, and they can request it again. Confirmation message. If all packets have been received completely, then a confirmation message would be sent to the sender. This would mean that they know that it was all fine. And some lost packages would mean that after a certain time, it would resend. Simple. So some packets must get lost in transmission, which I don't know how that happens, but I guess a checksum is a piece of data that we can generate from the header, from the packet. What can you generate it from? A checksum is a piece of data that you can generate from what? What are you generating checksum from? Checksum, we literally just went through this here, but where can you generate it from? Where is it coming from? From the payload. Payload. When data is received, the recipient can recalculate the checksum, compare it against the original, show no data has been, well, it's either lost or, what's the word? It's not encrypted. It's, I think it's not encrypted. There we go. Not close. So now, information in the header, is the sequence number, the client's IP address. It is the client's IP address. I'm pretty sure the client's IP address is in it. No, I'm pretty sure it is. No, I'm pretty sure it is. It's the send. Well, if you want to give the word senders or not, that's a bit peak. Don't tell me you're. So you give senders but you don't give clients. And what else is in the header then? So, sequence number. I don't think checksum's in payload. It says checksum, but it said 5 minutes ago that is in payload. Okay. What is the timeout limit? So, the maximum time that we can send per second, nope. The maximum amount of time the packet retains to transfer, yes. But I expect, because after that time, they fix it. They send it again. Processes on the sender's local. So the data is split into packets. The sender data application. The data is split into packets. Internet protocol as the address. Packets are grouped into frames and sent down the router on the LAN. Yep. This is kind of like a really trashy story. So the timeout limit. the maximum amount that we can time that will take transfer, no. Maximum time that the packet transfer is expected to take, yes, because if it takes longer than that, then it resends. And there we go. This took like, how long did this take? 6 minutes again. These ones are very, well, these are a whole lesson into one. So now it doesn't seem too bad. So network hardware. So we need a variety of different hardware to build a network. A switch, which can be used to turn things on and off. Routers, what you actually use to be able to send and receive information from the internet. The NIC, which provides the connections between the device and the network. And the WAP, or the wireless access point, which is the point at which you actually allow Wi-Fi to connect to the network. So router connects networks together. What does a server do? What the following pieces of information are hardware. This one, and this one. Simple. So, why is it important to use a WAP use encryption and authentication to allow users to bring up to make sure unauthorized, yep. So like people steal your Wi-Fi and garbage. So, transmission media, twisted pair copper cables. These are often Ethernet cables. There are 8 wires which are twisted into pairs, and these reduce the interface from other signals to improve transmission speeds. There are also fiber optic cables, I think. Will that be the next one? Don't freeze on me, please. There we go, fiber optic cables. These are made of thin strands of glass which transmit binary data as pulses of light. This doesn't traffic interface and has a high bandwidth, and is also very good for long distance communication. Coax cables, a wire transmission media which has insulated copper wire which surrounds some metal mesh to protect it from the interface and also help people. And radio waves are literally waves that allow wireless connection. This kind of slows it down and loses strength further away. So which are not true? Which of these are true of fiber optic cabling? They do not suffer interface. They are suitable for long distance. I literally said that and then I changed it to one which says it's not. So what material fiber optic cables make glass? Simples. A network something provider provides the connection between the device and the router. It's not the router, it is the Wi-Fi box thing. So this is radio waves are the transmission, the amplitude, well no. A network something controller. A network what controller? A network something controller. I've seen this before. A network something controller. Interface controller. Network interface controller. And then it is device network. Network interface controller provides connection between the device and the network. Perfect. And now, how many wires are inside the Cat6 Wi-Fi 8 and it's split into 4 sets of 2? So now, firewalls. Sure, we'll do Bhutan, but I have no clue where it is. It's quite close to India, you know. It's like at the hilly bit of the Asian border. So now firewalls. I have a billion questions being answered and sending off. Firewalls. It's important to monitor and filter data coming in and out of your network. Firewalls. A firewall is either a hardware device or a piece of software which sits between a device and the internet. Firewalls inspect and filter incoming and outgoing text packets. They try and stop hackers from getting into the network or to stop bad things getting in the network. Packet filtering. One role of the firewall is packet filtering. This inspects every packet that's going in, and some of them that don't meet the criteria would be dropped. IP address filtering. This would only allow certain IP addresses to be able to go on your network. And port blocking. It would block access to certain ports. So why is port 22 often blocked by the firewall? So that's because it allows remote access via the internet. Simple. Which allows hackers to get in. So the 3 techniques are packet filtering, source blocking, and port control. Port control is certain ports being blocked. Source blocking is certain IPs etc. being blocked. and packet filtering is certain packet meets a certain criteria being blocked. Firewall is either a something device, a hardware device, or a physical piece of software which sits between a device and the internet. It inspects and filters incoming and outgoing data packets. Simple. Imagine having an IRL firewall. Most of these are services offered by firewalls: port control, source blocking, packet filtering. Simples. Now proxies. So a proxy server is a computer which sits between a user's computer and the internet and acts on behalf of a user when accessing web pages. For example, privacy. The user's IP address is hidden by the proxy server, allowing random anonymous users to use the internet. Speed. They hold cache for regularly visited website, and that means that it would be quicker overall. And it would also link to VPNs, that means that you can look at stuff from across the world. Proxy server allows for what type of internet usage? Anonymous, so you can be safe while using the internet. Proxy servers are less secure than VPNs, as proxies don't something data. They don't like encrypt it. Well, VPNs do, but VPNs normally cost a lot more than proxies. So what user attribute is hidden? IP. Your IP address is hidden. See, this is some real speed right now. So now we have the last two, which is the client-server model and the peer-to-peer model. So the client-server model is the most common modern networking model. Is when computers on the network takes control of either the central server or a client. The client would request stuff from the server. They can easily get stuff. Everything is shared on one thing. That means that if you wanted to, you could very easily go onto any computer on that server, and you could sign in and do whatever you wanted to do. And the server would allow you to store files, host websites, etc. Would allow you to print. Would be centralized. So in the client-server model, the server is in control of the network, and it's known as a centralized network. So data exchange in the client-server model. So the client sends a request to the server processes it and responds. So you can monitor it easily. So a main administrator can make sure the rules, and you can easily change passwords and get files. It would have a centralized server, which means that there's easy access from any computer, and also it's quite secure because it updates everything centrally. So, can manage computers updates? No? Can manage computers software? Okay, can store files centrally, can easily share files, can apply software updates, and can manage the computer's what? Security. Security. Is it not? Can manage this? It can. So it can manage. You can manage computers' accounts, information. There's going to be something really stupid. Can manage computers centrally. Well, yeah, that's obvious now, but users might want to store their files on a server so that you can easily share their file from any connected computer, so any network, any computers on that network. So cons, security, it could be targeted by certain attacks. If the central server goes down, everything goes down. All the hardware could be quite expensive. Risk of downtime, yeah, I've said that one. And high cost. See, I know my thing. Which of these events could break an entire thing when a server fails? Imagine turns up computer, server. So, examples of services provide hosting websites, sharing files, and sharing documents. Printing documents. Yep. So you can print it from the same printer. What central management could a network administrator provide? Well, revival of lost files and passwords. Files and passwords. Along the client-server model, is mostly used, has many issues with cost and cyber attacks. Some small businesses may not be able to set up a client-server network because server is very expensive. So that's why people use peer-to-peer networks, which is what we talk about next. So peer-to-peer model. So these are like breaks in between, like give you a second or two, or maybe 10. So peer-to-peer. A peer-to-peer network, each computer directly connected together. This means there's no need for another server. This means you can easily transfer files, stream videos from one device to another. You can have wireless printing and Bluetooth speakers, etc. That means everyone is also responsible for everyone else and their own maintenance. Make sure they remain connected, and each computer would be known as a peer. Each peer can work as a client or a server. Each device is known as a peer, as a friend. In a peer-to-peer network, each computer is directly connected together. This removes the need for a central server. So, some networking problems are well suited to peer-to-peer networks, but others are suited to client-server solutions. In any case, you should weigh up your advantages and disadvantages. A peer-to-peer is a lot more robust because it has no centralized server. It's cheaper because there's no centralized server, and easy to set up. Wow. Some networking problems are well suited to client-server networks, while others are peer-to-peer networks. That's like really small businesses. What happens if one peer on a peer-to-peer network fails? So, some networking problems are well suited to peer-to-peer, whereas others are blah blah blah. File duplications. Files have to be duplicated and transferred between machines. This can be lead to multiple versions that become out of date. There is no centralized maintenance, that means everything has to be updated individually. And peers may lose connection. So no central management. Files have to be transferred between machines, and peers could transferred. This really doesn't help the fact that I can't spell. So transferred with 2 R's. Since when? Files have to be transferred between machines. Transferred. Duplicated. Yes, sure, duplicated. It's the same difference. So, what's the main issue with having duplicate files? They become out of date. It takes a long time to use the mod file, so it's your first one. Now, in a no, nothing needs to be said. No. And what about these networks easier to set up? Peer-to-peer, but you don't need a centralized to be able to do everything. And cons peer-to-peer. Files have to be duplicated between machines. Peers may lose connection at any time. Simple. I'm gonna string this out for another 10 seconds just so this reaches 45 minutes, and that's a nice number. So 4, 3, 2, 1.